Okay, now we're going to look at data manipulation with dplyr. So those of you who have seen dplyr before, this will be familiar. Those of you who have not, that's fine, this is your time to learn it. So we're going to be looking at dplyr is essentially a package for manipulating data. So rearranging rows, rearranging columns, picking which rows we want, picking which columns we want, creating new columns, summarizing data, and doing all the above by group. So we're going to be using some data of the students in New Zealand. It's at primary and secondary school. So we're going to read this data in directly off the web, and we see we have a large data frame of 103,598 rows with 5 columns. And so what this details is it details the number of students by school, gender, ethnic group and level. Okay, so you can see we've got one student at A1 Student Limited who's a female in the European ethnic group in year 10. Whereas we've got 3 students at the same school that are male of ethnic group European in year 5 and so on, right? Okay, so we're going to start by using filter. So if we run this, we can see that we can filter the role data by a condition. In this case, it's the condition that the ethnic group is Māori. Okay, so you can see that all of the observations here have ethnic group set to Māori, and there's now 29,126 of them. We can select more than one row, one column at once to do our filtering on. So, for example, this command here is going to filter all of the rows where the ethnic group is Māori and the gender is female. Right, that's the first one where we get 14,000 rows, so you can see the gender is female and the ethnic group is Māori. The second one with the vertical pipe character, which is above the enter or return key on your keyboards, that one is for or. So the comma is and, the pipe is or. So you can see here every row has either female for gender or Europe ethnic group set to Māori. Okay. And of course, some rows where they're both set accordingly. Okay. A couple of helper functions are is the %in% operator, and that's for when you want to select multiple options from a variable. So here we want to select whether the level is year 1 or year 2. And we can do that by just saying the level is in year 1 and year 2, which is a little bit less typing, particularly once you go through past multiple groups. So if we have a look here, we can see that we're just getting year 1 and year 2 students. Okay, so let's do some exercises. Find all the rows corresponding to Queen Elizabeth College students in year 9. So we're going to want the school set to Queen Elizabeth College. Alright, so that's got that school, so there's only 31 entries, and now we want year 9. So at the moment we've got year 10 and 11 and so on there. I'm guessing there's some year 9s further on. There we go. But we want the year level, so the year, so that we want the level equal to year 9. Okay. Real common mistake is typos. So, for example, using the wrong capitalization will give you no rows. Right? When that happens, my suggestion is if you have multiple things listed here, that you get rid of them. So, for example, we could get rid of the level, and then we see where the problem area is. Okay. And the other tip is to use copy and paste to your advantage. Okay, so if I copy and paste that, I know I get the right thing, and then of course I can go back in and put the level back in. So another common mistake I've just unintentionally made, notice I've just used the equal sign instead of 2 equal signs for equality, and R has told me about that. This usually means you've used equals instead of double equals. Did you mean level double equals year 9? Yes, I did. Thank you, computer. Okay, some other ones. Find all rows where there are more than 100 year 9 Asian students. Okay, so we've got 3 conditions here, I think. So we want to filter the range where the ethnic group is Asian, and the year level is year 9. And now we want to pick the rows where the number of students is more than 100. So there we go. So there's 9 rows where this happens. Okay. Notice that this is technically within the gender group. So we're only picking up rows which have the student number greater than 100. There may well be schools at which there are more than 100 students in year 9 of Asian descent, because of course we've got 2 rows, the male and the female are potentially could potentially be combined. We'll see how to do that later on. Okay, and this last one, find all rows where the school name starts with the letter G. Okay. So we're going to have a condition based on school, and there's a couple of ways you could do this. You could say school is greater than G, okay, to start to rule out any school starting with A through F. But of course you'll get the H's, the I's, the J's, and so on. So you could say and the school is less than H. That would reduce it down. The other way to do that is to use the hint starts. So starts, if we look at the help for that, I just press F1 to get to the help, by the way. So starts, detect the presence or absence of a pattern at the beginning or end of the string. So the arguments are the string, the input vector. So this would be our school. And then the pattern, the second argument, is the pattern in which the string starts or ends. So we want to find those that start with the letter G. And there we go. Okay, obviously those are the same. So that's how to pick rows. We can then arrange rows, so change the order, sort the rows. So for example, if we have a look at these ones, this one is arranging the school roll first by the gender variable, so we'll have all of the females first, and then within the rows that have female first, we'll then arrange by ethnic group. So you can see that we have all of the Asian students first, and then within ethnic group, because eventually we'll get, maybe if we go down, we may not sure if we'll have enough. Oh yeah, eventually we do. We see some year 10s there. Okay, so we get all the year 1s and then eventually start some other variable. Okay, so then we sort, so we're sorting by gender first, then ethnic group, and then level. We can also sort descending, so if we sort the number of students descending, then we find that the most students is 684 female European students in year 13 at Hagley Community College, and the second most students is the same number in Te Ahu or Te Kurapunamu, which I believe is the correspondence school. Okay, so try ourselves. Arrange the roll rows by the number of students. Okay, well that's just whoops, not filter, arrange. Roll by the students, easy. So we'll have the ones first and so on. Find all rows where the ethnicity is Pacific, arranging them by decreasing number of students. So this is going to be a combination of filter and arrange. So what we're going to do is we're going to do a filter first, where the ethnic group is Pacific. Alright, so that's all the Pacific students. So we'll call that Pacific. And then we're going to arrange that data set by decreasing number of students. Okay, and so there we go there. If we have a look across, the school with the most Pacific students in a particular year level of a particular gender is has 156 students, and that is De La Salle College. Okay, and the last one, which school has the highest number of international fee-paying students? It's got some weirdness happening here. Let's see if we can figure out what this might be. I'm just going to close it and reopen it. Okay, that looks better. Sometimes the editor can freak out a little bit. Closing the markdown and reopening it is usually the way to remedy the situation. Okay, so we're going to filter the role where the ethnic group is equal to international fee paying at year 13. So year 13 internationals. So let's have a look at that. So there's 337, so the ethnic group should be equal to international fee paying, it is, and the year level is 13. And then we want to find the one with the highest number of international fee paying students. So here we could actually just look through them, right? We've got our data frame up here, we could click on that and just have a look through. And just sort of scroll down here. So we've got a 22, 24, you know, it's not going to take too long, 25. There's a 36 and so on. We could order it in here, in fact. Order it descending. There we go, 220 is the answer, which is the UP International College of New Zealand. But of course we could just do that with a range, couldn't we? By descending number of students. And there we go, UP International College of New Zealand. Okay, now it's common here to answer questions with more than just one thing, right? So we've got two questions here, two examples here. We've used both filter and arrange in order to answer a question about some data. And you'll find that as you go, the processing steps you're required to take to deal with a particular data set often involves a whole heap of different options. So you'll be filtering, you'll be selecting, you'll be mutating, you'll be arranging, you'll be grouping and summarizing and all sorts of stuff. So you'll have a big sort of pipeline of commands that you're feeding the data through. And the pipe is for this. So instead of doing this set of code like we did, we could use the pipe, which is this version down here. Okay, so this here gives us the same answer, but is much easier to read and doesn't have the worry of all of these, you know, we've got all of these, we've got Pacific and year 13 int additional data frames, which were just sort of temporary things to answer stuff along the way. Okay, this is also, in my view, more readable. We take the role data set, we pass it into the filter command, and we filter out. We filter down to where the ethnic group is international fee paying. We then pass the result of that into the filter argument again, and filtered out such that the level is year 13, and then we pass that into the arrange argument. Okay, this could be written simpler because we've got two filters here that we could combine, so we could take this out and use a comma to put it in here, but we get the same idea. So let's perhaps do the one with the Pacific students using the same idea. So let's find where that one was. It was this one up here. Okay, so there's our original code. I'm going to rewrite this. We're going to take our role data, we're going to filter it such that the ethnic group is Pacific, and then we're going to arrange it by descending number of students. Right, so this is a more readable version of that same code, and of course will give us the same answer. Okay, so everything from now on will be using this pipe syntax. Okay, so that's filtering and arranging. So those are both concerning rows in the data. What about columns? So we can use the select argument. So we have some commands here. So select with a list of columns, we'll just pick out those columns. So you can see we've now only got 3 columns, school, ethnic group and students, because those are the ones we asked for. We can remove columns using the minus, and rename columns by specifying another name. Okay, so here we're going to remove the school column and we're going to rename the students column as number. So here we've removed the school column, we've only got 4 left, and the students column is now named number. And this last command is going to be picking out the students column, the level column, and then everything else, so all of the other columns. So everything is a nice little, it's called a tidy select helper that allows us to save typing everything out, right? If we just said select students and then level, we would have lost the other things. So this is a useful way of bringing columns to the left. Columns to the left are useful because you see them in the output straight away, right? So you'll see that I do this sort of same trick quite often. Particularly when we're adding new columns to a data set, by default they'll be added on the right. And of course, if you already have 10 or 15 columns, to look at that data set, you're going to have to sort of browse all the way to the right to find it, which is a bit of a pain. Okay, so let's try some ourselves. Rearrange the rows, the role data set so that the students and level are first. Well, we already did that, didn't we? That's just that one there. I'll make a note to change that one. Okay, rename the school column to name, keeping all of the other columns. So what we want to do is we want to take the role data set, we want to select name equals the school, and then we want to select everything else. Okay, so now we've renamed the school column as the name, and still retained everything else. Okay, now this is a common thing to need to do. So the other way to do, so there's a command specifically for it, which is rename. So the rename command renames the column you want and returns everything else to you in the original order. So for example, I could have renamed the students column and it would have left it where it was. So the students column is now named number. Okay. Right. So that's picking columns. What about adding new ones? That's what mutate is for. So you can see here that we're going to be adding a column called proportion, which is the students divided by the sum of the students. So let's see what that does. So you can see now I've got this additional column proportion. So what that's done is it's taken the students number and divided it by the sum of the students. So the sum of the students will be the total number of students, won't it? Because we're adding over all of the combinations of gender, ethnic group, level and school. So that'll be all students across all year levels, across all ethnic groups, across all genders and across all schools in New Zealand. So all schools in New Zealand. So this is the proportion of students in New Zealand that are in this particular set of categories. Okay, and the second command, what's that doing? Well, it's taking our role data and we are manipulating the level column. So we're taking the level column, let's break it down. We're running substring on it with an offset of 6. So what this is going to do is it's going to pick out all of the characters from character 6 onwards. So here you can see its year is character 1, the Y is character 1, 2, 3, 4, 5 is the space, 6 is the number. So what this command will do is just grab the numbers out of the level column, and then we're converting those numbers to numeric. So perhaps we could break this down, I suppose. So let's have a look and see what it's doing. So let's make a new column clean. It is just the substring level 6. See what that does. Okay, so you can see here that I've got this clean column here, which is just pulling out the number from position 6 in the string. So substring is for pulling out subsets of the string, right? Substrings of a string. But notice it's still of character type. So I could manipulate it again and convert it to numeric. Right, so now I have a clean column, which is the character, and then a cleaner one, which is the same thing converted to a number. Okay, and so that's what this step here is doing, what it's doing though is it's then overwriting the original level column. Okay, so we're changing the original level column to the numeric version of the same thing. So when I run that, I will get a clean data set, and when we have a look at that, the level column is numeric, so it sorts correctly, right? Last number's 15, first number's 1, which is more useful to us because now it sorts correctly. Previously it wouldn't have sorted correctly, so if we sort by the level column, for example, then all the year ones will be first, but let's arrange it descending. We would expect year 15, but we get year 9. Okay, and that's because it's been sorted as a character string, not sorted as a number, right? It doesn't know that the number 15 comes after the number 9. All it sees is the character 9 compared to the character 1 in the same slot, and says, well, 9 is after 1. Okay, so that's why we've done that. So from now on, we're going to be dealing with this clean version of the data set. Okay. Use the clean dataset, create a new column combining the ethnic group and gender using paste. Okay, so we take our clean dataset and we're going to create a new column with mutate, combining the ethnic group and gender. So we're going to go ethgen, call it what you like. It's going to be paste, ethnic group, gender. Okay, so if we go across here, we've got this new column ethgen, which is pasting those two things together. So you've got European pasted together with female as a single entry. Okay. Redo part 1 so that the original 2 columns are removed. So grab the same set of code and we're just going to unselect them, right? So we're just going to say we don't want the ethnic group and gender anymore, please. So there we go. So we've combined those 2 columns together into one. Got rid of the original ones. Now again, this is a common thing that we might need to do. So there's going to be a function for that, which we'll see in part 4. Create a new variable age with the typical age of students in each year level. Okay, and we've got a hint there that year 1 students are typically 5 years old. So what we're going to do is we're going to take our level variable and we're just going to add 4 to it. All right, so that when we go across here, those that are in year, level 10 are age 14, those that are in level 3 are age 7, and I guess those that are in level 1 will be aged 5. Okay, those that are in year 9 are generally 13 years of age, and so on. Okay, so that's how we do that. And finally, investigate using the unite function what you did in part 1 and part 2. So in part 1 and part 2 we were creating this new variable ethgen, and the idea is that there's a function in tidyr for that. So if we look at the help for the unite function, right, it's a convenience function to paste together multiple columns into one. So col is the name of the new column. So the new column is going to be our ethgen, and then ... are the columns to unite. So we're just going to put the columns to unite in here, and gender, and run that, and there we go. So you can see that by default it uses a separator of underscore. We can change that if we want. So we could use a space. And by default, it also removes the existing columns. So remove equals true, removes the input columns from the output data frame. So if we wanted the other ones there, we could just go remove equals false. And there we go, we've got our ethgen, and there's the old ones. Okay. So often, for really common things that you end up doing, there are helpers available for that. But you don't necessarily need the helpers. You can generally do everything with the kind of those base commands that we have. But of course, because some operations are done over and over and over, there's a helper for it. So feel free to use Google a lot. Add on tidyverse to your Google search when you're looking to do a particular thing. Okay, so the last two commands that we haven't looked at yet are summarize and group by. So summarize reduces our data set down to just a single row. So it takes all the rows in the data set, all 103,000 of them, and squishes them down to just one. Okay, so let's see what these ones do. So we're running summarize and we're creating a new column called rows, and we're setting it equal to n. So n is a helper for the number of rows. Okay, so here we go, 103,598. The second command then is doing two summaries at once. The first one is it's showing our total, which is going to be the sum of the students, so that'll be the total number of students across the country, because we're adding up the number of students in all of those different age groups and schools and ethnicities and genders. And then we're computing an average, which is the total over n. So let's run that. Okay, so this is the average number of students in each row. So total number of students, 826,347. So those are the number of students in school in New Zealand in 2020 or 2019, whenever the data set was created. And on average, there are 8 of each category. So the categories, of course, are by school, gender, ethnic group, and age, and year level. Okay, let's try some out here. Find the largest number of students in any row. Okay, so we could do this with a range. So we could go just clean arrange descending students. All right, and the answer is 684. But we could also do this with summarize, right? Because we're summarizing the student column, just reducing it to the max. Okay, 684. So it depends on what you want. Do you want the row, or do you want to know what the summary is? Okay. Find the median number of students in a row. Well, we found the average above, so we can do the similar thing. We're just going to want the median. There we go, it's 3. What is the lowest and higher? What are the lowest and higher year levels in the data? Again, we could use summarize. We could say lowest equals the min of the level, and highest would be the max of the level. Okay, and then find the number of Māori students in year 9. Right, so we want to take our data and filter down to the Māori students in year 9. And then we want to summarize that data by adding up the number of students. 16,420 Māori students in year 9. Okay, now the true power really comes from the group by operation, and this is what you'll be using quite a bit to answer a lot of different questions. And so this one here, essentially group by basically collects the rows together into some grouping structure, and then anything you apply from then on applies within each group rather than across the whole data set at once. But of course it does it all at once for you. So for example, this command here is going to group by school and then summarize the total number of students. So we're going to get the total number of students in each school. Okay, so we get one row for each school. We've got 2,500 schools, and the total column is the number of students in that school. Okay, so we can quickly answer these questions. How many students of each ethnicity are there? Well, that's similar to the above one, isn't it? So we'll take our clean data set and we will group by ethnic group, and then we will summarize total equals sum of students. Right, so that's the number of students of each ethnic group. So you can see there's 200,000 Māori students. Right, and 80,000 Pacific. I believe this is prioritised ethnicity, because kids can say perfectly validly, of course, that they belong to more than one ethnic group, and so prioritised ethnicity works by assigning a single ethnicity to those multiple ethnicities that answers that the students have given in a priority order. So, for example, the group with the highest priority in New Zealand is the Māori population, and then next after that is Pacific, and then next after that I think is Asian, and then European. Okay, so this is why the Māori group here is perhaps a little bit higher than you would expect, because there will be people that are, regard themselves as being both Māori and European, or Māori and Pacific, or Māori and Asian, and so on, or perhaps a combination of all of them. We have big, mixed population in New Zealand, which is fantastic. And so in this case, those people will have been put into the Māori group because we want a data set that represents everyone just once. So that's why that has been done. It's also done, for example, by the Ministry of Health. So, for example, if you look at vaccination data for COVID, it's done by the same technique. Statistics New Zealand often does things differently. So, for example, if the Statistics New Zealand is summarising things by ethnic group, then you'll find that the total number of people, if you add up across the ethnic groups, will be more than the total number of people in New Zealand, because some people are in multiple ethnic groups, right? So they do it slightly differently with multiple response. Okay, how many students are there of each gender? Same thing. So we'll group by the gender variable and summarise. There we go, roughly equal split, slightly more males than females. Which school has the most females in Year 13? Okay, so, well, we're only dealing with female students in Year 13, so we can filter our data. Alright, and then we can group by school and count the number of students. Okay, and then we want the one with the most. So again, we could just look down this line and find the one with the most, but the easiest way, of course, is just to arrange by descending total. Okay, so the answer is the correspondence school, which has over 1,000 females in Year 13. Okay. Produce a graph of the total number of students by year level. Okay. Just seeing how much more there is to go. I might split it into another one for the last bit there. Graph of the total number of students by year level. Okay, so we want to first create a data set that has the total number of students by year level. So we're going to, I think we've already done that, haven't we? Gender, ethnic group, school. No, we might not have done year level. Okay, let's do year level. Group by level. Summarize total equals sum of students. Okay, so there we go, number of students by year level. So we're going to then pop that into ggplot and use geom_col. So we're going to put our x is going to be our year level and our y will be our total number of students. There we go. So a couple of things you notice is that we have students at year 14 and 15. So I think those are students that are older, that have perhaps repeated a year earlier in their schooling careers and are completing essentially, so they'll be doing year 13 work I believe, is how it works. We also see this odd spike at year 7. I believe this happens because students are recategorized at year 7 into their actual year level. So because some students can come in at different times of the year, so for example, 5-year-olds start at school usually in the term that they turn 5, so they're not coming in all at the start of the year or the end of the year. So year 7 is where there's some data reconciliation, and that's why you get that odd extra spike there. Okay, alter your graph from 4 so as to include gender. Okay, so we want gender on the graph as well, so we want the sum of students to happen across gender. So what we're going to do is we're going to group by 2 variables. Let's just see what that does. So here's our data frame now. So we've got year level 1 female male, year level 2 female male, and the totals. And then we're going to do the same chart. So the same chart will work as is, get me exactly the same thing. It's just that now I've got the gender variable that I can use as well. So we could put, say we could fill by gender. Okay, there it is there. So again, the same shape. We've got the total number of students, so they're stacked bars here. So to compare males and females, we might want to alter the way the position works. So we'll dodge those bars rather than stack them. There we go, and we can compare the distribution of females and males. And of course, the interesting thing here is that there are more male students than females in total. We saw that earlier, and that happens on all the year levels up until a certain point. So at year level, I think this is year 12, 13, 14 and 15, there are more females than males. So males tend to leave school at the end of year 11. Some males, obviously, some stick around, and more end after year 12, and so you get schooling is then dominated by females because females stay in education longer than males do. Okay, I'm going to pause the video there and we'll have another one.